Welcome to A2 Wind Tunnel. Normally at this wind tunnel we test cars, motorcycles, bicycles, even things like solar panels, satellite dishes, trash cans, umbrellas. Today we're going to be doing something a little different, a little more fun and unusual. Is a hat more aerodynamic, forward or backwards? Let's find out. You can see here we've mounted a mannequin head in the tunnel. Obviously, no hair, no skin, so it's going to be a little different. So here we'll start with the hat forwards, but old habits die hard. Check and make sure we've got this at the proper angle. We'll go for 0 degrees, so the hat isn't more likely to flip up or flip down. 0 degrees is probably about where the average person would wear it. Here we are in the control room. I'm going to sit down. This is where I can work the fans, power the fans up and down, and collect data. So here at the bottom of the screen, you'll see the wind speed in miles per hour. In 3, 2, 1, go. This is sped up to 5 times the actual speed. I go up slowly because I want to make sure that the air has time to do what it's going to do. We're already at 10 miles an hour. Place your bets before we get there. Here we go, 20, 25, 30. Oh, looked like 38 miles an hour. Let's slow that down and check it again. Now this is actual speed. Video was taken. You can see there was a little delay, but it was 38 miles an hour. We take 2-second averages, so there's going to be a little bit of delay on the wind speed here. Let's slow it down even more. This is a quarter real speed, so we can see that hat really take off. Here we go. In 3, 2, 1, go. It's gone. Let's move on to the next orientation and see what we've got. Let's recover that hat and put it back on the dummy head. You can see no damage to the hat. We've got a catch net there just in case. It's caught many things, including several other hats, people standing in the wind tunnel while we're doing things like smoke. Here we go. We'll put that on backwards and we'll check the angle. You know what? 0 degrees. It's covering up the eyes. That's not realistic. Let's put this at a more realistic position. There we go. That looks pretty realistic. I think that's how the average person would wear a backwards hat. And let's check this angle, just in case we want to repeat this test. We'll know exactly where we set it. Looks like that's about 27 degrees there. Here we go. Again, we're at 5 times the normal speed. Now's the time to place your bets. Remember, the hat forwards was at 38 miles an hour. Is this going to be higher or lower? We're already up to 20 miles an hour. Going up fast. 38 has come and gone. Where is it going to be? 48, 55, 60, 67 miles an hour is what it looked like if it did not even touch the ground. Here we are at a quarter speed. You see it actually get caught in the net. Slow it down even more. 5% or 1/20th speed. And right into the net. All right, here's a surprise for you. I know a lot of people would have eventually asked, what about hat sideways? Now's the time to place your bets. My bet would be it's going to come off a little lower speed than the other ones, but we flew right by 38 miles an hour. And here we go, right by backwards hat. Well, there you go. The tunnel wind speed's actually topped out at this point. I would not have guessed that result. So the tunnel can actually do up to 85 miles an hour with something like a standard car in there. If you think about it like putting your thumb over the end of a hose, the higher the blockage is, the higher the speed of the water coming out of the hose, right? Same thing in the tunnel. And when we've got a big car in there, the wind speed's higher. Let's do a repeat on that real quick and make sure we got the same results. There's nothing sticky on the head. Nothing should be holding it on. There we go. Same result. 78 miles an hour and it can hold up. Time for a little tunnel ASMR. Most of the work that we do in the tunnel is actually measuring the forces that are being exerted on something like a car. Now, for measuring the forces acting on this, we're going to want to make sure that hat doesn't move. So I've gone ahead and added some duct tape so that we get consistent measurements. Now, that may add some interference, but as you can tell, this isn't going to be a perfect simulation anyways. For one, there's no body attached to this head, which would actually affect the streamlines and likely make that hat come off sooner by deflecting some of that air up into the hat. Let's go for it anyways. For these tests, I'm actually going to collect about 3 minutes of data. Obviously, I'm not just going to show you the tunnel running for 3 minutes. So here we are, we'll be looking at the coefficient of drag for the hat forward. Now you'll see here we've got several different numbers. So the two numbers here are each 77-second averages. We always take at least 2 points so that we can see if there's any big variations between the data points. We know that something shifted and we need to go back and look at that. But as long as those two are relatively close, we're just going to be looking at the yellow, which is the average of the two data points. So here we've got a drag coefficient, or a CD, coefficient of drag, of 0.757. That doesn't mean a lot until we compare it to hat backwards. Hat backwards, we've got a drag coefficient of 0.754, so just slightly less than the hat forward. You can see here just 3 counts less than the hat forward. Now you may be wondering, if it's only a little bit less drag, then why did the hat forward take off the head so much quicker than the hat backwards? With the hat forward, that bill was exposed to the wind. So when the wind was hitting the face, some of it was deflected upwards and would lift that hat right off of the head, versus the hat backwards, the bill was relatively hidden, so it would be difficult for the air to lift it up and take that hat off of the head. Here we go, hat sideways. We've actually got a drag coefficient of 0.883. Now that is 129 counts, or 0.129 more drag than the hat backwards at a 754. That makes sense. We had the bill exposed to the wind. The wind was seeing a lot more surface area. The bill sideways is not going to be very aerodynamic. Now, what's this all mean? The 757, 754, 883, we should really be removing the head alone from that equation, because we're just really looking for the drag the hats make. So I went ahead and did that measurement also. So no hat, much lower drag coefficient. So the dummy head alone, 642 counts, 0.642, which if we compare to run number 2, up here, that's 754, which was our lowest drag. This is 112 counts less than the hat backwards. Basically meaning just the hat backwards is going to be 112 counts. And we go up from there. Feel free to leave comments below. Were there things you liked or didn't like about this video? Do you have any ideas for wind tunnel tests we should do? We will be posting more videos, likely one every couple weeks. Until then, feel free to check out our website, a2wt.com, for some interesting FAQs about how our wind tunnel works. You can check out our Instagram, just A2 Wind Tunnel, or our Facebook, A2 Wind Tunnel, for pictures and videos of what we've done in the past. Until then, stay aero, my friend.